Text: The evolution of bacteria on a megaplate petri dish. Harvard Medical School.
So what we ended up building was basically a petri dish, except that it's 2 feet by 4 feet. And the way we set it up is that there are 9 bands, and at the base of each of these bands, we put a normal petri dish thick agar with different amounts of antibiotic.
The setup is displayed, along with the 2 by 4 foot dimensions. An illustration shows the 9 bands across the surface of the setup. White lines divide the black bands.
On the outside, there's no antibiotic. Just in from that, there's barely more than the E. coli can survive. Inside of that, there's 10 times as much, 100 times, and then finally the middle band has 1,000 times as much antibiotic. And then across the top of it, porous and thin agar that bacteria can move around in.
The outermost bands are labeled 0. The next band in on each side is labeled 1. The bands inside those are labeled 10. The bands inside those are labeled 100. The innermost band is labeled 1000. Arrows extend inward from the left and right sides.
The background is black because there's ink in it, and the bacteria appear as white.
From above, cloudy white fills the outermost bands of the setup.
First, you see they spread in the area where there's no antibiotic, up until the point they can no longer survive. Then a mutant appears on the right.
An arrow points to a small white splotch in the black space just inside the white band on the right.
It's resistant to the antibiotic, it spreads, until it starts to compete with other mutants around it.
Other splotches appear near the edges of the white bands on either side and grow in the adjacent black space.
When these mutants hit the next boundary, they too have to pause and develop new mutations to make it into 10 times as much antibiotic.
With the 1 times bands nearly filled with white, splotches expand inward into the 10 times bands.
And then you see the different mutants repeat this at 100.
The white expands inward, into the 100 times bands.
And after about 11 days, they finally make it into 1,000 times as much antibiotic as the wild type can survive.
Cloudy white splotches begin to reach into the innermost band.
And so we can see by this process of accumulating successive mutations that bacteria, which are normally sensitive to an antibiotic, can evolve resistance to extremely high concentrations in a short period of time.
Lines connect dots in the white space on either side. The lines and dots become warmer in color as they near the center, with the outermost dots being blue and the innermost ones being red. Text: Harvard Medical School. Research and video by Michael Boehm, Tammy Lieberman, Eric Kelsick, Remy Chait, Rotem Gross, Danielle Lean, and Roy Kishany. Narrated by Michael Boehm. Edited by Rick Rouleau. Music courtesy of Extreme Music. Under the Knife written by David Russell Fleming and Jörg Huebner. Copyright 2016, the President and Fellows of Harvard College.